Hey everyone, today's video will be solving the problem jump game. So the question says you're given an integer array nums and you're initially positioned at the array's first index and each element in the array represents your maximum jump length at that position. Return true if you can reach the last index or false otherwise. Okay. So what the question is basically saying is that let's assume that you have an array nums with these as your values 2, 3, 1, 1 and 4. Okay. Now, what you need to do in this question is you're initially placed at the index 0. So you're placed over here. Okay. So you are currently over here. Okay. Now, what you need to do is you need to check if you can reach the last position. And how would you reach the last position? So the index at which you're at has a number at that place, right? So right now at index 0, we have a number 2, which means that we can move either one space or two spaces. So if you're over here, we can either move one space to this point or two spaces to this point, right? So we need to check that if we move one space to three, right? Now, when we move one space to three, we can move when we reach at any index, right? So let's say we're reaching at point index one over here, we just take one space. So now when we're at, we have a array nums of I, which is three this point, okay, at the very first index. So when we're at three, we can take three spaces from this point now. Now, when we take three spaces, we can go here, here, or here, which is the last point. So over here, we can reach the very last index from the given array. So this is what the question is, guys. So you can either take one step from here or two steps. When you take one step, you can take three steps from here. Now, if you take one step over here, you can still reach the end. Like if I don't, directly jump and take three spaces, if I just take one jump over here, I can reach. I go over here. When I'm at this index, I can take one more jump. I can take one jump when I'm at this index. So when I take one jump, I can come over here, and when I'm at this index, I can also again take one more jump, and I can reach over here. So this is what, and again when I take this jump, I can reach the end of the array. So this is what the question is, guys. Okay, I hope you understood the question. Now to solve the problem, what we're going to do is we're going to use the greedy approach in this problem. For this video, there are two ways to solve this problem. Is one is using DP and one is using greedy. For this video, I'm just going to use greedy and explain you how you can solve the problem. Right. Now, to solve the problem using the greedy approach, what you can do is rather obviously. So let's just talk about the recursion approach just for a short while. So using the recursion approach, what if you think about the recursion approach, right? You'll need to use all the occurrences you have. So let's say you're at point index one, index zero here. So you'll need to check with index when you take one jump and when you take two jumps, right? You need to check if you reach the end of the array when you take both those jumps. And when you take one jump, you need to check whether that one jump has three more jumps, right? So you need to check with each individual jump. So the recursion tree would be something like this. So let's say I'm over here, I have two, right? I can take one jump to three and or two one jump or two jumps to one. Now when I'm at three, I can take one jump to one. I can take one jump to one and one jump to four. Now, when I'm at one, let's make a pipe over here. So when I'm at one, I can just take one jump to one. And similarly, now when I'm at one, I can just take one jump to, one over here. When I'm at one over here, I can take just one jump. And when I'm at four, I'm already at the end. So I don't need to take any jump. And when I'm over here, I take one jump. Then over here, again, I take one jump and reach 4. And after this, I'm reached the end of the array. So this is what the recursion tree would look like. So I'll need to, you know, do a lot of brute forcey things just to check if I reach the end of the array. Okay, I'll need to check all the possible outcomes I could have. So when I'm at 2, I'll need to go to 3 and then with 1. Then when I'm at 3, I'll need to check with 1, 1 and 4. Then I need to check for 1 with 1, then this one with 1, and then 4. We need to check whether it is, if it is the end of the array, or does it have more, branching out to be done. So this is what the recursion method would look like, and it's like a complete brute forcey approach. But you could optimize this using DP. But the greedy approach is actually much more easier and simpler because it solves a problem in O of n time. So what the greedy approach says is that you need to have a goal, and your goal is the very last index of your array. Okay, so let's define it over here. Define a goal over here, which is the very last index of your array. So this is going to be a goal over here. Right. Now, what this question says is that when you're at your very last index, right, you don't need to check whether all the above and all the values ahead of it are reaching it or not. Just need to check whether the very previous one, just the one previous before that, is it reaching the next one or not? If it is, let's say we come over here, right? We have to check whether if when we are at this position, can we reach this position or not? Right. If we're at this position, we can reach this position when we take one jump. So if we can reach this position, we just need to, make this position, which is the index right now, as our goal, current goal. Okay. Now, when this is our current goal, we need to do the same procedure. We need to check if when we just need to check if the very previous element or with the previous index we have, if the element over there has the number of jumps which it has. Let's say if we had a zero over here, we would have just returned a false because you can't take any jump from this point, and we can't reach that. We can't reach our goal over here. Okay, but we still have a 1 over here, which means that we can reach our goal. Right now, our goal is this index 3 over here. 0, 1, 2, 3. Yeah, our index 3 over here is our goal right now. So we can, when we are in this position, we can take one jump and reach this index. Similarly, if we can reach this index, we'll just make this position as our goal. Now, when we have to check if this position, from this position, can we reach our goal or not? Yes, we can. If we just take one jump, we can reach this position, and we just make this our goal right now. And for this question, and for this index, you can just see that we can reach this index from this point by taking one jump. So you you can reach your goal, and so this becomes your goal right now. And if your goal is equal to zero, you just need to return a true. And if it's not, you just need to return a false. So I hope you guys understood what the algorithm is like. So when you're at this position, you don't need to check for all the values. You just need to check if the very previous value just before it is reaching your goal or not. And every time if it does reach a goal, you just make that current value, your current index value, your goal. Okay, so like over here, if when the one was reaching, when we are index 3, we reach this point, we can, after taking one jump, we just make this our goal. Okay, so let's code this problem out, guys. So right now we're making a goal equal to the very last element. Now we'll loop through from the very last element in our array, length of nums minus 1 to minus 1 to minus 1. Okay, now what we'll do is we'll just check if our current index plus the value present as an index is greater than or equal to our goal or not. If it is equal to greater than or equal to a goal, we just make that goal equal to that current index, and and this is it, guys. We'll just in the end we'll just see if our goal is equal to zero or not. If it is equal to zero, we'll just return a true, and if it's not, we'll return a false. So what is happening over here is we're checking if that the current index. So let's say our I is over here. So our I is at index number 4 over here. Okay. The index is equal to 4 at this point. So we're just checking if our index 4, let's write a goal over here as well. A goal is also index 4, right? We're just checking if index 4 plus the nums of I, which is again 4, whether index 4 plus that nums of I, which means that the current index plus the number of jumps, maximum number of jumps it can take, whether it's exceeding our goal or not. In this case, it is exceeding. So we have 8 over here, so it's exceeding. So our goal will turn to I, and we'll go forward in the loop. When we go forward in a loop, we'll just make this goal equal to I. In this case, it's going to be again 4, and we come over here at 1. Now, when we come at 1, what we're going to do is we're going to check if our current index, which is 3, plus the nums of I, which is 1, whether it's greater than or equal to goal or not. So right now our index is 3, and if we take one jump from 3, we can reach our goal, which is 4, which is equal to our goal. So this means that we can get to our goal position from that current index. So we'll just make that current index equal to our goal. So this will become 3 will become our goal now, and we'll just go back in the loop, and we come over here. Now, when we come over here, again, we'll check if I, which is 1, will, is it, if we add it with the nums of I, so whether 2 plus 1 is greater than or equal to 3. So right now, again, it is equal to 3. So we'll just make this equal to this index, our goal, and we'll just come back over here to this point. Now, when we come back to this point, we'll again check whether if our index plus the nums of I is greater than or equal to goal or not. In this case, again, it's 4. It's greater than goal. So which means this is going to be our goal now, and we'll reduce our I. And when we reach our last index, we'll check again if 0 plus 2 is greater than or equal to 1 or not. And right now, again, it is greater than a goal index. So we'll just make this goal equal to 0. And when we make a goal equal to 0, which means that we reach the end of the array, which means that it is possible to reach from the very first element to the last element in this array nums. Okay. So yeah, let's just run the code, guys. And yeah, and let's submit this. Yeah, it's submitted, guys. So, yeah, guys, that's all for today's video. If you like the video, do like, share, and subscribe. Do check out my podcast and do let me know in the comments if you have any more questions or if you want any specific question to be solved. Until next time, guys, thanks for watching.